Hi, we're going to move to the object-oriented programming section of the worksheet. My senior mentor, Jemmy, made these slides, and I think they're pretty helpful. So let's use them. There's another object-oriented question. I'll do that in the next part, I guess, back on the iPad. So this problem is making two classes, a food class and a salad class. Let me turn on a pointer. Okay, cool. So food class and a salad class. And the salad class is a child of the food class. So all salads are food, basically. So the salad class inherits from the food class. And then we make all of these objects. So we have lettuce, tomatoes, chicken, ingredients, and my salad. So the first three are just food. Ingredients is a list that contains lettuce and tomatoes. And then my salad is of type salad, and it takes in this list of ingredients. So initially we have these classes, food and salad, and we kind of just write down what methods they have. It's pretty helpful to do this. The way Jamie suggested was that you can sort of just draw the classes in squares and then objects in circles. And that'll help you distinguish between the classes and the objects. So we have both of these classes, they have some methods, and then we make all of our bindings. So lettuce is bound to an object of type food. Oh, sorry, they're not squares and circles. I guess they're different colors here. But yeah, just make sure you have some sort of way to distinguish between objects and classes when you're doing these. So lettuce has name lettuce, because in the constructor, we passed in lettuce, and we said self.name is equal to name. Num days is 0, and spoiled is just false by default. Tomatoes is the exact same thing with tomatoes, and chicken is the exact same thing with chicken. Then we have this list of ingredients that points to both of these. So it points to the lettuce, and then it points to the tomatoes. All right, and then lastly, we have our salad. And let's try to figure out what that'll do before we reveal it. So salad is going to be called on ingredients. So that's going to be this ingredients variable right here. And then it's going to call super.init with salad and false. So that is like calling food.init, but passing in the self argument. So this is just a longhand for that, a shorthand for that, sorry. Yeah. And so we're going to pass in only two arguments, salad and false. So name and spoiled. And that means that our self is already filled in. So our self is just going to be our salad. So what will happen is we'll say self.name is equal to name. So our name is just going to be salad. And then we're not going to be spoiled. Okay. Then we're going to say self.ingredients is ingredients. So salad actually has these extra instance attributes. So namely, it's this. So basically what I described, name is salad, spoiled is false, ingredients points to a list. All right, let's move on. Here's our WWPD. So the first one we have is lettuce.canEat. So we go to lettuce, and then we look up canEat. So there's no canEat associated with the lettuce object. So we look in the class, food. So there's a canEat right here. What that does is it increments self.numDays, okay? And then it returns not self.spoiled. So since spoiled is false, that'll just return true. So lettuce.canEat is going to return true, and then change numDays to 1. All right, so numDays changed to 1, and we return true. Then we do mysalad.canEat. My salad is not a food class, not a food, but the salad class actually doesn't have a canEat method. So then it's going to look in the food class and then call this canEat method. What it'll do is increment the number of days. So they'll go from 0 to 1, skip all of this, and then return true. So in the salad class, let's watch the number of days. That becomes 2. And then that returns true. I believe we skipped a step here because this changed to salad lettuce for some reason. Let me go back. Okay, sorry. Yeah, that was just the next part. So my salad.mix ingredients is the third one. I guess you have a little bit of a hint of what that'll do, but let's see. So we call mix ingredients. We iterate through the ingredients in the ingredients list, and we call mix food on that ingredient. So self.mixFood is going to call the mix food. It's going to look in the salad class because self is a salad, but it's not going to find one. So we're going to actually call this mix food right here. And the parameter other food is going to be each element in our ingredients list. So the first one is going to be the lettuce class. So we're going to say self.numDays is equal to self.numDays plus other food.numDays. So that's going to be salads days plus lettuces days. So it's going to first become 3. All right. And then self.name, we're going to add other food.name to it. So we're going to add lettuce to the end of it, as Jemmy did here. And then spoiled is going to become self.spoiled and other food.spoiled. So this is only going to be true if both of these are true. And we know that they're both false. So this is just going to say it's not spoiled. All right. So the next iteration, we'll iterate and we'll do tomatoes. So tomatoes, we'll say self.mixFood of tomatoes. And then we'll go here. We'll say numDays is actually now our current number of days, which I think we said was 3. And then, 2, plus other food.numDays, tomatoes.numDays. That's just a 0 at the moment. So we add tomatoes to the end of our name, and our numDays remains 2. Okay. And then let me just move these. Okay. And then the last thing we did was in this method, we printed your salad has been mixed. So that'll be printed here. And then my salad.name is just going to return the name that we have right here. Yeah, that's the WWPD. I will move to the linked list question on the iPad. Okay, so we're going to do this next object-oriented programming problem, and this is going to be a doubly linked list class. So we're familiar with linked lists, where you have a value and then a next element, which just links to another linked list. And then that linked list has a value and a next element, which links to another linked list, until the end, where the next element is just empty. So that's sort of how we've been working with linked lists. Well, this one says that instead of just having a next, you also have a prev attribute. So a prev attribute is going to keep track of the linked list behind you. So this is useful because, well, sometimes you might want to go backwards, right? So let me just expand these. So each of these can have another box. So in the middle, I'll put my element. At the right, I will keep the same thing, the same next. But in the left element, I'll keep a pointer to my previous one, like so. So when you construct a doubly linked list, we have to change the constructor a little bit. And let's look at the behavior that we want. So if you make a doubly linked list with 6, whose next is a doubly linked list with 1, then list.value is 6. Okay, so we know there's a value attribute, so self.value is equal to the value that's passed in. And then list.next.value is 1. So list.next, that's just this list right here, .value is 1. Okay, so we know we have to set a list.next, so self.next is whatever was passed in as next, which is by default just empty. The last thing we have is list.prev.value errors. So that means list doesn't have a prev here, and prev is conveniently just going to be by default this empty thing. So we can say self.prev is equal to prev. All right. So that's our constructor. It was pretty much just the assigning of variables. Let's figure out these two questions. So the first question we have is add last. So this just means add to the end of the linked list. Okay, so let's see how we do that. So what they've given us is pointer, which points to self, a while loop, and then some sort of assignment to a linked list. So let's make our pointer pointer, and that starts at the front because that's just self, right? Then to add to the end, we somehow want to move this pointer along. So take this arrow, move it to the next element, and then the next element, and then we want to say, okay, you're the last element. So instead of having your next be empty, I'm going to make it a new list with whatever element I want. Let's say 10. And then the prev is going to be pointing that way. All right? So the way I can do that is I'll iterate, and in my iteration, I'm going to say pointer is equal to pointer.next. So each iteration, wherever pointer is, I'll move that arrow along 1. But I only want to do that until I get to the last element. So once I get to the last element, how do I know I'm at the last element? Well, the last element's next is empty. So while pointer.next is not empty, and then we get to the end. And then what do we want to do? Well, we're at right here, and we want to set this guy's next to be the new doubly linked list. So that'll be pointer.next is a doubly linked list with value, whatever value we were given. What's the next element? The next element is empty, dlist.empty. And the prev element right here, this arrow, is going to be our pointer. Oh, sorry, I have the wrong prev element. The prev element for this list with 10 is going to be where our pointer is. So pointer. And yeah, that's add last. So I will come back and do add first. I'm going to go get some dinner. All right, let's do add first. I recommend you guys try this one on your own. It's pretty tricky, I think. So yeah, hopefully you're able to do it. So pause the video and come back. All right, so what I'm going to do is I'm going to draw a sample linked list. Let's say it has 5, and then I'm going to draw a long arrow to the next element. And let's say that's a 3. And if you recall, these boxes that I have on the left and the right, as opposed to just having one box for next, the left box is the previous pointer and the right box is the next pointer. So let me erase these. Okay. And what we want to do is we want to change, so this is our self, this is our linked list. We want to change the front value to be the value that's passed into us. And then we want to, somehow we want our final linked list to look like this. So let's say the value that was passed in was 10. We want our final linked list to look like that linked list with 3 elements. But the problem is that we can't just like add a node at the front here and then like somehow have our self point to that node, because the self is just a local variable, right? So we have to actually mutate the object such that this front node stores the value 10, and then we insert this 5 node in the middle somewhere. So let's try to do that. So we did the first thing, but we don't want to lose the 5 node. So let's make a new node here that sort of copies the 5 node. So it has a 5 value. Its next is this 3 node, and its prev is going to be our new self. Okay? And then we can change the value of our node, as I did earlier, to be 10. All right? So that's almost what we want, but we have a few pointers messed up here and there. So let's make that first variable. So they conveniently declared a variable old first for us. And what value is it going to have? Well, it's going to have the value that first used to have, which is just self.value. Remember, this box used to have a 5 in it. I just changed it. All right. Then we need its next and its prev. So its next, well, if it used to have a next, then we can set it to that. So that would be self.next. And its prev, well, we want its prev used to be empty, but now we want its prev to be our new front. And our new front is referred to by self. All right. So now we have some things working. Let's see what's wrong. So one thing that's wrong is that we haven't actually set the value of this node here. So this here is still a 5. So let's change that. We'll say self.value is equal to the value that was passed into our function. And in this case, we made that 10. Okay. The other thing we have to do is change this arrow that I'm about to erase, because that points to the wrong next element. The second element of our list is this node with a 5. So we want to be pointing to that node. Okay, so we say self.next is equal to our old first. Remember, old first is pointing to this node right here. Okay, and the last thing we want to do is this arrow from the 3 is messed up, right? This arrow from the 3 should be pointing back to the 5 node. So we want to do that, except if the node with the 3 didn't exist, that would have been a problem, because we would have been just trying to assign things from an empty list. So that's why we have to check if old first dot next is not empty, so dl list dot empty, then we want to say old first dot next, which is this right here, its previous value is just old first. So that would take this arrow right here and then point it exactly where we want it.